Now we will see a demonstration of how Phase 1 may proceed. First, we need to decide on a way in which the identity of the remote host is confirmed. The IPsec allows us to confirm the identity of a remote computer by checking its account with the Active Directory domain using the Kerberos protocol. We can also verify the certificate issued for a given computer. This solution is used most often. The third option should be used only for testing and demonstrations. It's the shared secret verification. The shared secret is a string of characters recognized by every computer that is to take part in the IPsec communication. Establishing a secure channel consists of the exchange of challenge-response messages. Challenge-response protocols are widely used for remote authentication of both computers and users. This is also how the LM and NTLM protocols, the two protocols which we'll discuss later on, work. The underlying principle is the same. Differences concern only technical details. One party must generate a pseudo-random challenge message and send it to the computer it wants to exchange data with. The receiver should be able to use the challenge to calculate a response and send it back. The response, when decrypted, should verify or authenticate the identity of the remote host. For this, the shared secret is used. It can be the short secret, a certificate and a public key, or a password that would start up a computer in Active Directory. An important feature of the IPsec is that it allows mutual authentication. It requires both parties to authenticate or prove their identities. Both parties must be sure who they exchange data with. Phase 2 is relatively simple. It consists of confirming or changing the negotiated security association and generating new session keys. Let's see how, in the simplest case, the configuration of IPsec could look. We'll learn how to do it in Windows 7. In Windows 7, you should use the MMC console to perform all administrative operations. In this operating system, the IPsec was integrated with the network connection firewall. Therefore, you need to find the local computer tools that allow you to configure the security policies of the network firewall. In practice, this type of operation will affect all the computers in the group. Once defined, the settings will apply to all the computers that are members of the group. In this version of Windows, the IPsec policies are set as part of the firewall configuration. In earlier Windows systems, the IPsec policies could be configured independently of the firewall policies, but resulted in many people accidentally blocking communications between computers. Users often created conflicting rules. The first question of the wizard concerns the type of rule you're creating. As you can see, the IPsec can be successfully used to block certain hosts. With the IPsec, you can completely block data from subnet X or subnet Y. In our demonstration, we will try to create a rule allowing secure exchange of data. Now we need to specify which computers this rule will apply to. In the simplest case, both fields can be left blank, which means that the rule will be universal. The Customize option allows us to choose the type of interface. The next question is critical when it comes to the security of our rule. The default option, Request, means that an attempt to negotiate the IPsec security associations will be made. However, if the other party does not agree to the negotiated security association, the data will be sent as a clear text. In all wizards, the Request option makes it possible, but not required, to negotiate security associations. The Require option, on the other hand, means that if the other party does not agree to the negotiated security mechanisms, the communication will not take place. The next step is to select the remote host authentication method. This can be a certificate issued for the computer, or, after selecting the advanced option, a computer account in the domain. Each computer and each user as well has an account in the Active Directory domain. This account is password protected and the passwords are regularly changed. Another method is authentication with a pre-shared key. It's not recommended to use this option. Everything you type in this box will be visible to anyone who will create a similar solution in the future. You can define more than one authentication method. This is connected to the Security Association's negotiation we mentioned earlier. If an attempt to negotiate one of the mechanisms fails, the next one will be tried out. The next step is to determine whether the rule being created is to apply to private, public, or corporate networks. At the end, you type the name of the rule. We've created a rule which is by default enabled. It protects both inbound and outbound connections. This is a very general rule. In practice, such rules are hardly ever created. It applies to all kinds of protocols. The rule enforces the authentication of the remote host by checking whether it recognizes the information we've provided in the wizard. It affects networks of all types. Theoretically, the principles behind the IPsec may seem uncomplicated. The implementation of this protocol is very simplified in the domain environment where we can use Kerberos. The wizard we have just gone through also greatly simplifies the implementation of the rules. However, the fact remains that the implementation of a set of rules that effectively protects the communication with various servers requires thorough planning of the whole mechanism.